Good evening students, welcome back to our BSc first year physics class. In last lecture, we discussed about the gradient, divergence and curl of vector. Just quick review on last lecture, then we will discuss some numerical problems related with the gradient, divergence and curl. Okay, first of all, we are defining a del operator, that is del is equal to I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z. We are using that del operator in gradient, divergence and curl. It means gradient, divergence and curl are the applications, practical application of a del operator. Okay. Now, gradient. The component of gradient in the direction of a unit vector is called a directional derivatives of that function. It may be phi, it may be psi or whatever it may be. Means when a del operator operates on a phi where phi is the function of x, y, z, then del phi is equal to I kappa dou phi by dou x plus j kappa dou phi by dou y plus k kappa dou phi by dou z is nothing but the gradient. In case of divergence, we are taking the dot product of del operator with that function. If that function is v, f or whatever it may be, if we take the dot product of del operator with that function, it gives del dot v is equal to dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z. Means if we take the divergence, then resultant quantity is must be a scalar. In case of gradient, the answer of or the resultant quantity of gradient is a vector quantity. Okay, this is the main difference between the gradient and divergence. If we move forward, in case of curl, if we take the curl, in that case curl is nothing but the cross product of del operator with a vector a or vector v. If we take the cross product of del operator with a vector v, then I kappa by dou x plus k j kappa dou by dou y plus k kappa dou by dou z cross product of v1 I plus v2 j plus v3 k, it can be written in the form of determinant which is equal to I j k dou by dou x dou by dou y dou by dou z v1 v2 v3. If we solve this cross product or if you solve this determinant, finally we are getting dou v3 by dou y minus dou v2 by dou z I kappa plus dou v1 by dou z minus dou v3 by dou x j kappa plus dou v2 by dou x minus dou v1 by dou y k kappa. Means if you take the curl, in case of curl also we are getting the vector quantity. Okay. Now on the basis of this divergence, curl and gradient, we are going to solve some numerical problems, in which first problem del in bracket f plus g is equal to del f plus del g, we have to show that. Second, del into fg is equal to f del g plus g del f, where f and g are the differentiable scalar function of x, y, z. Means what? F and g are the functions depends on x, y, z. Therefore, del f plus g is equal to dou by dou x I kappa plus dou by dou y j kappa plus dou by dou z k kappa into f plus g. If we multiply f plus g inside the bracket, it gives I kappa dou by dou x f plus g plus j kappa dou by dou y f plus g plus k kappa dou by dou z f plus g. Now, if you multiply this derivative differentiable quantity with f plus g, it gives I dou f by dou x plus j dou f by dou y dou g by dou x plus j dou f by dou y plus j dou g by dou y plus k dou f by dou z plus g dou g by dou z. If we collect f term individual and g term individually, finally we get I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z into f plus I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z g. It gives del f plus del g. Hence we can prove del in bracket f plus g is equal to del f plus del g. Similarly, in second numerical, we have to show that del into fg is equal to f del g plus g del f. How that we can solve, or we can show that? We know the value of del, which is equal to I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z into fg. If we multiply fg inside the bracket, it gives dou by dou x f plus g I kappa plus dou by dou y f g j kappa plus dou by dou z f g k kappa. Now f and g both are the functions which depends on x, y, z. Means we can differentiate this f and g with respect to x, y, z. Okay, it means what? Both f and g depends on x, y, z. That's why we have to use UV formula, differentiation UV formula, which tells us differentiation of first term, second term as it is, plus differentiation of second term, first term as it is. By using that formula, we can solve f dou g by dou x plus g dou f by dou x I kappa plus f dou g by dou y plus g dou f by dou y j kappa plus f dou g by dou z plus g dou f by dou z k kappa. Now if we collect the f term individually and g term individually, we get f dou g by dou x I kappa plus dou g by dou y j kappa plus dou g by dou z k kappa plus g dou f by dou x I kappa plus dou f by dou y j kappa plus dou f by dou z k kappa. Now if we separate that, it gives f del g plus g del f. In this way we can solve this, or we can prove this numerical problem. Now next, in this problem, what differentiation from the point 2 1 minus 1 is the directional derivatives of phi is equal to x square y z cube x square y z cube a maximum, that we have to find out. Means we have to find out gradient, that is del phi is equal to del into x square y z cube x square y z cube. If we substitute the value of del, which is equal to I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z into x square y z cube, if we multiply x square y z cube inside the bracket, in that case first we have to differentiate with respect to x, it gives 2x y z cube, y and z cube both remains as it is, 2x y z cube I kappa. If we differentiate with y, it gives x square z cube j kappa plus 3x square y z square k kappa. Now they are giving x, y and z coordinate. If we substitute that value, x is equal to 2, y is equal to 1 and z is equal to minus 1, then gradient of phi, that is del phi is equal to minus 4i minus 4j plus 12k plus 12k. sorry. Next, in third problem, in third numerical, a given function a is equal to x square z I kappa minus 2 y cube z square j kappa plus x y square z k kappa. We have to find out divergence of that vector quantity a, which is equal to del a equal to dou by dou x I kappa plus dou by dou y j kappa plus dou by dou z k kappa dot the value of vector a is x square z I kappa minus 2 y cube z square j kappa plus x y square z k kappa. Now, if we multiply or if we take the dot product of del operator with a vector a, it gives dou by dou x square z plus dou by dou y minus 2 y cube z square plus dou by dou z x y square z. If we differentiate with respect to x, it gives 2xz minus 2xz minus 3 into 2 minus 6 y square z square plus x y square. Now, in this numerical problem, I want to find out the divergence of a vector a at a point 1 minus 1 1 1 minus 1 1. If we substitute the value of x y z, x is equal to 1, y is equal to minus 1 and z is equal to plus 1, then it gives 2 into 1 into 1 minus 6 into minus 1 square into 1 square plus 1 into minus 1 square. It gives a minus 3. Means the divergence of a vector a at a point 1 minus 1 1 is minus 3. Okay. Now next, if phi is equal to 2x cube y square z raised to 4, then find out del dot del phi. Means first we have to find out the gradient, then we have to take the divergence of that gradient quantity. Okay. Then first my aim is to find out del phi, which is equal to I kappa dou by dou x plus j kappa dou I kappa dou by dou x into phi is nothing but 2x cube y square z raised to 4 plus j dou by dou y 2x cube y square z raised to 4 plus k dou by dou x 2x cube y square z raised to 4. If we differentiate with respect to x, it gives 6x square y square z raised to 4 I kappa plus 4x cube y z raised to 4 j kappa plus 8x cube y square z cube k kappa. Now, in this way we are getting the gradient of a that given function phi. Now, next step is to find out the divergence of that gradient del dot del phi. It gives I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z dot 6x square y square z raised to 4 I kappa plus 4x cube y z raised to 4 j kappa plus 8x cube y square z cube k kappa. Dou by dou x into 6x square y square z raised to 4 plus dou by dou y 4x cube y z raised to 4 plus dou by dou z 8x cube y square z cube. If we differentiate with respect to x, it gives 12x y square z to the power of 4 plus 6x cube z to the power of 4 plus if we differentiate with respect to z, it gives 24x cube y square z to the power of 2. Okay, in this way we are getting the del value of del dot del phi, del dot del phi. Now, in second case, we have to show that del dot del phi is equal to del square phi, is equal to del square phi. First, we will find out the left hand side, that is del dot del phi. I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z dot dou phi by dou x I kappa plus dou phi by dou y j kappa plus dou phi by dou z k kappa. Now, if we take the dot product of gradient, it gives dou by dou x dou phi by dou x plus dou by dou y dou phi by dou y plus dou phi dou z dou phi by dou z, which is equal to dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. If we take phi outside, it becomes a dou square by dou x square, dou square by dou x square plus dou square by dou y square plus dou square by dou z square into phi, which is equal to now del square phi. We know the Laplacian operator del square, which is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Therefore, del dot del phi is equal to del square phi. Now, next, in next numerical, a vector A is x z cube I kappa minus 2x square y z j kappa plus 2y z raised to 4k kappa. Now, my aim is to find out the curl of that vector quantity at a point 1 minus 1 1. Therefore, del cross A is equal to I kappa dou by dou x plus j kappa dou by dou y plus k kappa dou by dou z cross x z cube I kappa minus 2x square y z j kappa plus 2y z raised to 4k kappa, which is equal to determinant of I j k dou by dou x plus dou by dou x dou by dou y dou by dou z x z cube minus 2x square y z 2y z to the power of 4. If we solve this determinant, it gives dou by dou y 2y z to the power of 4 minus dou by dou z minus 2x square y z I kappa plus dou by dou z x z cube minus dou by dou x 2y z to the power of 4 j kappa plus dou by dou x minus 2x square y z minus dou by dou y x z cube k kappa. If we solve the differentiation, it gives 2z to the power of 4 plus 2x square y I kappa plus 3x z square j kappa minus 4xy z k kappa. Now, if we substitute the value of x, y, z, where x is equal to 1, y is equal to minus 1 and z is equal to plus 1, then del cross A is equal to 3j plus 4k only, 3j plus 4k. In this way we can solve, or we can solve curl of any vector quantity by using gradient, divergence and curl. Okay, these are the numericals based on divergence, curl and gradient of a vector quantity. If you have any doubt related with this divergence, gradient and curl, you can ask me anytime. Now, in tomorrow's lecture, we will discuss line integral, surface integral, volume integral and some numerical problem related with the line, surface and volume integral. Thank you.